Harrison and John's actuarial skills.
What's up, John?
What's up?
Bet I can score more points than you.
But you can't.
Let's go to the statistician and find out.
Do it.
What's up, statistician?
It's good.
My friend John and I have a problem.
What's that?
We want to find out what's the probability of one of us scoring more points than the other.
Well, let's use our actuarial skills to find this one out.
Alright, let's get to it. Okay, the statistician estimates that John's total points through one quarter in a game is uniformly distributed on the interval 0-5, and Harrison's total points through one quarter in a game is uniformly distributed on the interval 0-10. The statistician assumes that the two total scores are independent of one another. What we have to do is find the probability that John will score less points than Harrison.
First, we have to ask ourselves, what type of uniform distribution is this? It is continuous, since the total number of points is represented by a dense interval, which is the total number of points can be anywhere from 0 to 10 for Harrison or 0 to 5 for John. It does not have to be any set number. Continuous uniform distributions are given by the density function f of x equals 1 over b minus a. A plus b equals the boundaries of the interval. B equals 10 for Harrison and 5 for John, and a is 0 for both. For John, the function is 1 over 5 minus 0, or f of x equals 1 over 5. For Harrison, it's 1 over 10 minus 0, and f of x equals 1 minus 10. Independent, you have to think of it in terms of set notation. Probability of A times the probability of B, which would be 1 over 50, which is the combined density function for our problem.
Now that we know the combined density function, we have to integrate it. One strategy we can use to do this is drawing a diagram, like so. Looking back to what the problem was asking, find the probability that John will score less points than Harrison. In other words, this means that Harrison's total points should be greater than John's. This means that the probability of Harrison scoring more is greater than the probability of John scoring more, which implies that Harrison's point total minus John's will probably be greater than 0.
One way to look at this is to acknowledge that every probability is uniformly distributed, which implies that we can simply look at how much of the region the shaded area takes up out of the whole figure. Let's start with the area of the triangle. Equals 1/2 base times height. So the area of the unshaded region equals 25 over 2, because base is 5 and the height is 5. 25 over 2, because 1/2, so you have to divide it by 2. Now the area of the total region is 50. Base is 10, base is 5, height is 10, 5 times 10 is 50. Now the area of the shaded region, we have to do 50 minus the area of the unshaded region, 25 over 2. So So 50 over 1 becomes 100 over 2, and 100 minus 25 is 75, so we get 75 over 2. Now, 75 over 2 is 37.5, and 37.5 out of 50 is, so the probability of shaded region equals 3/4, or 75%. So the probability of Harrison scoring more points than John is 75%.
We chose our content area because we thought that being an actuary might be an interesting career, so we decided to make it our topic to find out more about what an actuary really does.
This project enhanced our understanding of probability that we touched on last year in geometry. Overall, we thought that this project helped us gather a deeper understanding of how algebra is used in everyday life.